What is singular value decomposition, SVD, in machine learning? Imagine trying to make sense of a huge pile of data that seems overwhelming. What if there was a way to break it down into smaller, more manageable pieces? That's where singular value decomposition comes in. It's a mathematical method that helps us understand complex data by splitting it into simpler parts. In machine learning, especially in unsupervised learning, the goal is often to find patterns without labeled examples. One common challenge is dealing with high-dimensional data, which can be hard to analyze or visualize. Singular value decomposition helps by reducing the number of features or dimensions, making the data easier to work with. The process involves taking a matrix, which is just a way to organize data in rows and columns, and breaking it into 3 smaller matrices. The first matrix, called U, contains what are called left singular vectors. Think of these as directions or patterns in the data. The second matrix, called sigma, is a diagonal matrix with numbers called singular values. These numbers tell us how important each pattern is. The larger the number, the more influence that pattern has on the data. The third matrix, V transpose, contains right singular vectors, which representing features or items in the data. In practical terms, if you have a large data set with thousands of features, you can use SVD to keep only the most important singular values and their associated vectors. This process reduces the data's dimensions, making it easier to visualize or analyze. It also helps in cleaning up noisy data by discarding smaller singular values that often correspond to random fluctuations rather than meaningful information. SVD is used in many applications. For example, in recommendation systems, it helps find hidden patterns in user preferences and item similarities. In image processing, it can compress images by keeping only the most significant parts, reducing file size without losing much quality. It is also useful in natural language processing, where it helps analyze large text datasets by capturing the main themes or topics. In the context of unsupervised learning, SVD is a key tool for simplifying data before applying clustering or other pattern-finding methods. For example, in facial recognition, it reduces the complexity of facial features while keeping the essential details. This makes it easier for algorithms to identify faces accurately. It's important to remember that while SVD is powerful, it also raises ethical considerations. If the data used contains biases, the patterns it finds might reinforce those biases. So, it's essential to use diverse and representative data when applying SVD in real-world AI systems. Overall, singular value decomposition is a fundamental technique that helps make sense of large, complex datasets. It streamlines data analysis, improves efficiency, and opens doors to many exciting applications in artificial intelligence and machine learning.